If you're looking for the content sharing the benchmarking results between the Collector and Fluentbit version 2, then this episode is for you. Welcome back to the Is It Observable YouTube channel. Today's episode is part of the OpenTelemetry and Community series where we covered, in fact, many episodes. If you paid attention, I recently released an episode comparing Fluentbit and the Collector. So this episode was focused on comparing the feature of both agents. And today's episode will be focused on sharing the benchmarking results on both agents. And again, to be able to compare both agents, I will need to explain precisely the process in building this benchmark. If you enjoyed today's content, don't forget to like and subscribe to the channel. So let's see what you're going to learn out of this episode. We'll start by explaining the benchmarking logic and how to compare both solutions, and especially what type of pipeline we would be using. We will then explain the two environments, the one for the Collector and the one for Fluentbit. Last, we will jump into the tutorial where I will walk through the various results seen in those benchmarks. To be able to compare both agents, I have built a GitHub repo with all the various Collector and Fluentbit pipeline. So here is the link to the repo that will be used for this tutorial. To stress each agent, I'm deploying two demo applications, the Hipster Shop in one end and the OpenTelemetry demo. So the quantity of data sent to each agent will basically depend on the load applied on each application. If there is more load on each solution, then it means that the application will produce more traces and more logs. In terms of metrics collected, we will focus on collecting CubeSat metrics, node exporter. Because we are having Istio in this environment, we also collect the metrics produced by the Envoy, and we will add another exporter, Kepler. In the case of the Collector, we will use cumulative to delta processor to export the metrics to the expected format of Dynatrace, which is delta. Because Fluentbit is not supporting the metric conversion, we will need to export it into a Prometheus format, all those metrics, and let the Dynatrace operator collecting the metric produced and convert them on the fly. It's a feature available in the Dynatrace operator. In terms of trace pipeline, we won't do much with it. We will basically receive the traces and export them. But for the Collector, I will add some enrichment using the Kubernetes attribute processors. In terms of logs, we will collect logs from the cluster. Because each agent has the similar feature, we will build a more advanced pipeline, so collecting the logs, parsing the logs to extract few fields, enrich the logs by adding Kubernetes metadata, and add few resource attributes. So all the signals will be sent to the same backend, which is Dynatrace. Last, we want to report the behavior of both agents, so we will enable the telemetry data produced on both agents. Comparing each agent by collecting metrics, traces, and logs at the same time does not make sense because there are few minor differences in the pipeline design. So we will split the test by having test with the pipeline collecting only logs, test with the pipeline collecting only logs and traces, and last test with the pipeline collecting logs, metrics, and traces. For each of those tests, I have prepared two families of tests. So a ramp-up test that will be 2 hours long. Every 30 minutes, I will add 50 users on each application. So at the end of the test, we have 200 users on the Hipster Shops and 200 users on the OpenTelemetry demo. And last, we will run a soak test of 24 hours where both applications would have 50 users running during the entire test, so during 24 hours. Regarding Fluentbit, we won't use the traditional pipeline format, but we will take advantage of the new YAML syntax that will allow us to take advantage of the processors to do some minor actions when receiving logs. Last, we will let the Dynatrace operator to collect the resource usage of the various pods, the workload, and so on. So at the end, we would be able to also look at the CPU and memory utilizations of both agents. To run all those tests, we will need, of course, one specific cluster for Fluentbit and one cluster for the collector. So you can use the same cluster, but avoid running both tests on the same time, because at the end, it will be difficult to compare. To build this cluster, we'll need, of course, a Cumulus cluster with 2 nodes, the data trace operator, the OpenTelemetry operator to deploy our collectors. In fact, this operator requires the cert manager, Fluentbit, so that will be for the Fluentbit test, of course, the Kepler exporter, the Prometheus operator to have the desired exporter that we want, so the CubeSat metrics and the node exporters, and our 2 demo applications, so Hipster Shops and the OpenTelemetry demo applications. Because of the limited support of OpenTelemetry on Fluentbit, supporting only OpenTelemetry HTTP protocol, we will have 2 distinguished versions of the OpenTelemetry demo application. So one for the one for the collector will basically have one collector receiving all the telemetry data produced by the application, which is metrics, traces. So we will use a daemon set collector. For Fluentbit, we will need to translate the protocol used. So to do that, we will inject a collector sidecar in each OpenTelemetry demo pods. So the OpenTelemetry demo will first export to local hosts, and the sidecar collector will only be there to translate OpenTelemetry gRPC into the OpenTelemetry HTTP protocol supported by Fluentbit. And Fluentbit, in that case, will be deployed as a daemon set. If you are paying a bit attention to this repo, there are 2 branches. The master one, which will be Fluentbit 2 versus the collector, and then the other one with Fluentbit v3, where I have adjusted the pipelines with the Fluentbit 3 logic. So here in this recording, I will try to show you more the Fluentbit v3, because I think you will probably be interested in this in those numbers. But anyway, to deploy the environment, it's going to be similar to the Fluentbit v2 or v3. It's going to be the same. You need a Cumulus cluster. So pick JKE if you want. In my case, I'm using it. Make sure you have two nodes with significant CPU and memory, because it will require a significant number of resources. In this tutorial, I'm sending the data to Dynatrace. So if you have a Dynatrace tenant, not a big deal. Otherwise, you will have to start a trial, and by put your email address, you will get your tenant in few minutes, or and then once you have the tenant, there are a few things that you should be focused on. Is, of course, saving the tenant Dynatrace URL. So if you look at this is my tenant here, in the URL in the top here, you have this is going to be your URL. So make sure to grab the entire URL until.com with the HTTPS, because it's going to be one of your environment variable for the deployment scripts. The other thing that we need is an access token. So you can go to apps and type token. Access token, here it is. And then you will press on the generate a new token, and there are 2 tokens that you need. So I've already created those. There is a one for the operator token and the one for the ingest token. For ingest, make sure to have the biz events, the events, the logs, the ingest metrics, write metrics, and of course OpenTelemetry traces, because we're going to send traces, logs, and metrics to with the Dynatrace tenant. And collector, both the collector and Fluentbit will be observed using the Dynatrace operator. So here that's why you need this other token. So the operator token in one hand and the ingest token in the other hand. So that's why you have different type of scopes that are required to interact properly with your Dynatrace tenant. So once you have created those 2 tokens, make sure, like it described here, to save in the Dynatrace tenant URL, like we mentioned, the API token. So that's going to be your operator token. And then you have the data ingest token. That's going to be the one that we're going to use for the operator, but also in Fluentbit, and in the OpenTelemetry collector. In this specific repo, I'm using Istio.
So here, the main one was the Istio 1.20.1. I think the other one is 121, but it doesn't matter. Install both. You just need to have istioctl enabled, because the script will rely on istioctl. So once you have done, you have two deployments, one from Fluentbit and one from the collector. So pick and choose. So here I'm going to mainly focus on the Fluentbit side. I already have run all those tests in all the environments. So you will have to run the agent type Fluentbit scripts, or the agent type collector if you're running the collector instances, because at the end we are going to have different tests, one set of tests on Fluentbit and one set of tests for the collector. All right, so now let's look at what you should expect from this environment. So if you look at the namespaces, there are a few things that you should see here. Of course, you have Istio system, which is the technical namespace for the control plane of Istio. We have the OpenTelemetry operator systems for the OpenTelemetry operator deployment, and this requires cert manager, so that's why cert manager is also deployed in this environment. Here I have the Fluentbit namespace, because I'm showing you the environment with Fluentbit. And in all the collector will be sitting in the default namespace. And then to add extra exporters, I have Kepler. That's why there's the Kepler namespace. And then, of course, we have the R2 applications. Ipsoshop is in one hand, and the OpenTelemetry on the other hand. So, but if you look at the pods of the default namespace, you will have, of course, the Prometheus stack, node exporter, kubestat metrics, because we will try to collect those metrics exposed by those two exporters. And here, because I'm using the Fluentbit v3, in this particular case, I'm using a collector. That's the difference with the Fluentbit v3 and Fluentbit v2. In v2, I used a sidecar collector to make the transformation and send to Fluentbit. In this case, I decided to make it simpler and lighter, to use a stateful set collector that will be there to translate the protocol, because remember, Fluentbit doesn't support gRPC, so the collector will be mainly here to translate the gRPC protocol to the HTTP OTLP protocol. In the application side, if we look at briefly, starting with the OpenTelemetry demo application, you can see that we have all the various parts of the application, OTel demo application. The front proxy is crashing. Don't pay attention, because we're not using this this workload. And you can see there's two containers, because Envoy is being injected in this namespace. And same thing from the Ipsoshop, where we also have two containers, except for the load test, which is a cron job. So that's why I'm not injecting any Envoy here. But we will have two containers per workload, because we are having Istio in each of those workloads. The other thing that we have is, if we pay attention to, we can see that we have two instances of Fluentbit, because Fluentbit here is collecting logs, and the rest as well. But because we're collecting logs, we are deploying it as a daemon set to be able to read all the logs from the cluster. So if you go back to Dynatrace, if you want to see that everything is running smoothly, you will have to go to services. So you can click here, apps, and search for services. Here it is, you have services here, and that will show you all the services that is producing data in your Dynatrace, in this Dynatrace tenant. So we can see that we have the hotel demo services with each envoy, and also we have the other services, which is the Ipsoshop. So this is what you should expect. You should have the OpenTelemetry demo in one end, and the Ipsoshop fully instrumented by Ipsoshop is instrumented by the one agent, but OpenTelemetry demo, of course, is done by only OpenTelemetry. So if I click on one of those, for example, if I pick the checkout services of the hotel demo, we should have some distribute traces generated. So for example, I click on place order, I should see a full end-to-end trace, including the various spans from the envoy perspective. So this is as a requirement. Same thing if we want, we can also drop in the logs, but the best is to go to the Kubernetes application that's going to be utilized, and we'll see that I have my cluster. There are several workloads running here, and if we pick, for example, one of the deployments from, let's say, the card services, you will see that if we look at that card services workload, if we click on logs, you will see that the logs are coming in. Those are the logs at the moment. From now, it's looking at the logs sent by Fluentbit. But if you do with the collector, you should have the similar experience because the collector is going to do the indexing. So this is basically what you should have when you deploy the environment. You have the app running for the first tests. You will have some data coming in. Of course, depending on the test that you're running, if traces are not sent, you won't see traces. That's normal. In terms of results, one important aspect is that if you look at this repo, there is a Dynatrace folder in the repo, and this has the Dynacube, but it also has two JSON files, the collector and Fluentbit. Those are two dashboards that I use to basically compare things. In fact, I have added more dashboards in my end to do the comparison in more easier. So here, we're looking at the Fluentbit dashboards, where I'm looking at all the information about the inputs. So the number of bytes received per minute, the number of records, because they have two KPI, bytes and the record, number of file opened. And then we go to the filter sections, where we do also a couple of data stats about the number of records and so on. And then we do the same thing for the output. And last, we can look at the resource usage in terms of CPU. And then we can see here the memory usage in terms of memory. And then, so I have the same thing with the collector. So here I have no collector running, so I will have to grab some tests, some data. So here, but I can see the various data going through the receivers. The advantage, like described before, is that in the episode is that the collector has more dimensions on the metrics exposed, so which is great because I can differentiate the number of log received, the number of metrics received, the number of trace received, and same thing for the refused. And then when you go to the processor sections, same thing. I can also do a look at each signals separately. And what I like is the fact that you can see which plugin is you can do a split by plugins. So you can see that few plugins are not exposing metrics, which is it could be improved from my perspective. And last, we have the exporter. So same thing, we look at the number of log exported, the metrics exported, and the trace exported. And then I have the specific collector process sections where the collector expose the CPU per minute, the heap size, the allocated bytes, the system memory, and so on. And last, I'm using this is coming from the Dynatrace operator to expose the metrics consumed, the CPU consumed by the actual pod, and same thing for the memory. And then, of course, I'm looking at the difference between in and out to see if there is any major problem. To be able to compare, I have decided to do a Fluentbit versus collector dashboards that help me to compare things properly. And then I have another one called Fluentbit comparison. I built this dashboard, Fluentbit comparison, to compare Fluentbit v2 and Fluentbit v3 because I have the dates of those tests stored somewhere. And you can see the blue line is a Fluentbit v3 and the black line is Fluentbit v2. And what is interesting is not on the pipeline itself, it's more on the resource aspects, is Fluentbit v3 is consuming less CPU than Fluentbit v2. So that's, at least I thought it was interesting. So they are doing some optimizations and that's pretty amazing. On the memory side, same thing. If you look, we were about 50 megs when we were doing log traces and metrics. And with Fluentbit v3 with a new processor and doing more actions on the metrics, I was expecting to see a more memory consumed, because at the end dealing with metrics could be very memory intensive. But here it's the even better. I'm consuming about 35 to 40 megs to the same type of load. So that's quite surprising from my perspective. So here I'm grabbing a test for the Fluentbit 24 hours tests, and I will compare it with the similar test with Fluentbit v3. The blue line is Fluentbit, and the black one is the collector. So in terms of metrics, we're gonna not look at that deeply. I'm more interested in this piece here. It's basically the 24 hours test is 50 users on the Observable shop and 50 users until the OpenTelemetry demo during 24 hours. And what you can see here, the Fluentbit v3, I have about 100 millicore stable during 24 hours. On the collector side, yeah, it starts to increase significantly. And what is more interesting is the memory usage that is growing a lot, 10 gigs, and then crash and restart. So the collector, it seems that there is a problem on the way. We are scrapping the metrics. Since that, I have shared some P profiles with the OpenTelemetry community. And what is really consuming a lot of memory in this pipeline is the sections for Kepler. And this is the section with Kepler. And you can see that it's the only relabeling config that is actually doing some label drop. And this is more, for some reason, very intense in terms of resource usage. So that could be also, there's two parameters. There is the scrap interval that is too short. So I may have increased it to 30 seconds to maybe be more gentle with the data that comes in and all the actions that the collector has to be achieved. Last thing that I've done, I have done the test of target allocator, and I want to see the difference. So here I've selected the dates for the target allocator test, 24 hours tests. So we see the logs received, the trace, and so on. So we have the similar stats. But what is more interesting is first on the collector processor. We have obviously less CPU consumed. The heap size is less important. The allocate bytes, same thing. And then in terms of CPU utilizations, we are similar to the other test, almost about 200 millicore. I have an Hotel D, so the daemon set collector that collects the logs. So the target allocator will be only used for the metrics and traces. And the memory, you can see that it's going to max 1.2 compared to 10 gigs. And I have the same pipeline that I showed you before, where we have the label drop in the service monitor in that case, and pod monitor, and I have also the scrap that is quite very intensive. And you can see that in terms of resource, it's almost the footprint is much more lighter compared to the experience that we had utilizing only the collector. And then the target allocator itself is about a couple of millicore of usage and few 60 megs of memory consumed. So it's almost nothing. So basically, if you sum up all the resources between the collector to collect the metrics, so and the one for the logs, we are obviously require less resources. I may have more workload, of course. One daemon set, so 2 instances of my collector in my case. So about here, you can see here, we're looking at about 200 megs for the logs. And the other one, the two other collectors, as a stateful set, consume about 1.6 gigs. So we are about 1.2 gigs globally, 2 gigs plus 60 megs of memory required for target like allocator. So way less important resources compared to the normal collector that will jumping into roof in my specific use case.
That's it for today's episode, sharing the benchmarking results between the Collector and Fluentbit 2.x. As you can see, I think for logs, Fluentbit is a tremendous agent. Fluentbit 2.x, because of course we have lots of powerful parsers, and from the resource perspective, it's really lightweight. So 15 megs of resources for the logs, it's insane compared to the collector, which is more heavier, about 90 megs in general. When we introduce the traces with the logs, we can see that Fluentbit consumes a bit more memory at the ends, but not a big deal. I think the collector is still stable as well in terms of resources, so not a big deal as well from the collector perspective. In terms of CPU, we can see the similar behavior, but what is interesting is when we introduce the metrics collections. Of course, the collector has more tasks to run, so with a relabeling config, by using cumulative delta and so on. But clearly, when we introduce the metric collection on the collector, we can see the memory consumptions increasing significantly. And when we run those soak tests, we can see that there is obviously potentially problems in the configuration or a memory leak on the Prometheus receiver of the collector. I have opened a GitHub issue on the OpenTelemetry contrib repo related to the Prometheus receiver about this potential memory leak. I will try to add a pprof and so on, so the community will have more details to resolve the potential problems that we have seen with the collector. And as you saw at the end, I did an extra test using the target allocator. And when you see the behavior of the target allocator, technically, if you are in a Kubernetes environment, I would recommend to use the target allocator, because the metric, the usage of the collector is way much stable. And if you sum up all the resources required between the target allocator and the collectors, at the end, we're consuming much less resources than just a collector for metrics. All right, so if you enjoyed today's content, don't forget to like and subscribe to the channel. So see you soon for another episode. Bye.